Hello and welcome back to Hadoop Exam Learning Resources. In this session, we will be covering the part where we left. Correct. So this is the place where we have left. Okay. I want to recommend here actually if you feel this training is going very slow, then there is a settings in the videos, correct, in the disk side of corner most of the time you see, and you can increase the speed from there 1.5 times 1.x times whatever is available on the video setting, correct. So that would help you to if you feel it is a slow, because we cannot every person has a different learning capability, correct. So accordingly we have to maintain the speed, correct. So you can change it. Okay, so now let's move to the this where the I will place. Okay, so iterative algorithm with the Hadoop map reduce. This is what is exactly the Hadoop where it is different actually. So when you submit your map reduce job, what and you have to do the multiple iteration on the same data. So what HDFS this Hadoop framework does is it reads data from the HDFS file system, process this data and save this data back to the disk. Then again in the next iteration it will read from the disk and save and process it and save onto the disk. So this is will keep doing it. Okay, and even when you see we have in the Hadoop framework we have map and reduce phase, correct. Map phase and reduce phase. So what it does is actually if each computer is working in your cluster, so if it is processing some data, correct, so it first read from the disk this data, correct. From the disk it would read the data. In the map phase whatever it produce save on the disk, correct. Whatever produce save onto the disk. Again in the reduce phase again read from the disk and then do the reduce phase, read from the disk and do the reduce phase, read from the disk. So what is happening here is reading from the disk is a crime if for the performance war. If you want to have a high performance, you should not always for each step like read right from the disk. Once you read it first time, obviously you have to read from the disk, correct. Once you read it from disk, then keep data in your RAM until your processing completes. So keeping in RAM give you the huge advantage, like easily make your process 10 times faster, at least 10 times faster I would say. Okay, and then you can do as many time as many iteration you wanted to do on this data, you can do that on this data, correct. So now let's assume it reading data from disk is much slower as I discussed. Okay, so now here in the same in the image I have shown you like how this reading from disk is very slow process. Okay, so that you should avoid it. So where the Spark took the advantage and like everything it does in the RAM and release the data until it completes the processing, correct. So Spark keeps data in memory instead of disk. It reads once and keep into the RAM. Even your computer which is holding data in RAM is crashed, Spark knows how to load it again. So don't worry, fault tolerance and all this thing internally maintained by the Spark framework itself. So it is a well mature framework which can do this. Your data loss and everything would be, even Hadoop can do that, correct. But it keeps data in memory, okay, whatever calculation you have done. So how come Spark can be have a big data in memory now? That is the problem, correct. We are saying we need to process 10 terabytes of data and we are talking about like keeping every data in memory. So how would it possible? Again this is a cluster, correct. 10,000 nodes of clusters and each node has a 256 GB of RAM. Then you can assume it how much data it can hold in the computer, correct. So you can see, so this much RAM is available in the cluster, so it can hold in memory. Even if it is not capable of holding data in memory, it can use the disk, so your processing would still be done, but it would have some performance issues if data is not in the RAM, correct. But it can do processing even if your RAM is not enough to process huge volume of data, it read from the disk. But even there are lot many other things which Spark has done other than reading from the RAM to make it faster. Okay, so that is one reason it keeps data in memory. Okay, as uh, it is very fast. So that is one reason we can say. Another reason, Spark uses modern hardware caches very efficiently, which is not being done in the Hadoop framework. What you see, I'm not sure how much you are aware about the caches in the modern hardware has actually. If you see, your machine would have multiple CPUs nowadays, correct, CPU core. So suppose a high-end machine comes with a 16 core CPU. So each CPU is also had attached cache, that is memory. Okay, cache is memory only. That is first the cache which is attached, which is known as L1 cache, level 1 cache, which is very near to the CPU. So whatever in L1 is there would be very quickly processed because this is on the same chip, on the same hardware on your computer, correct? L1 caches, so it is capable of processing. And above that there is another cache which is little far from the L1, that is L2 cache, correct, which is there. And for the all the CPU one shared cache is L3 cache, correct? So L1, L2, L3, and then after that your RAM come into the picture, correct? Fourth level you can say RAM, correct? So that is where like L1, L2, L3, every cache Spark try to use it. And this is part which is big project actually, that is known as Project Tungsten, which is Spark has uh, is work for the using the modern hardware or whatever hardware capacity is available. Spark trying to use it as much as possible, correct? So that is the another reason where it make fast. Okay, third, one of the most popular and mostly developer also involved in this, that is Catalyst Optimizer. Okay, so this is new framework they have developed. Okay, this whatever code in a you submit not using native API, if you use high level API like data frame dataset, that all use the Catalyst Optimizer. This whatever way you write the code, Spark knows how to optimize your code and process it. So it internally does it. Spark has its own data types. It's like Spark is a one of the programming language you can assume is internally. The programming language has the data types their own, correct? So similarly Spark has their own data types, correct? So Spark has its own optimizer, which is Catalyst Optimizer. For each data type, Spark has an encoders. So serialization, deserialization you have heard of if you know from like how to transfer data over the network, correct? You need to serialize and deserialize. The Spark created their own encoders. They have their own serialization mechanism. So this is again very optimal. So in the Catalyst Optimizer there are tens of reasons and tens of places where they have made it optimal, correct? So Spark has various, we would be covering Catalyst Optimizer in the next session in detail, actually how it makes like a very performant engine kind of thing, correct? So here Spark has various strategies. Again the predicate push down, I'll cover this later on. Okay, this is concept you need to understand. Okay, Spark does not use Java inbuilt garbage collection mechanism, correct? You know Java has a GC, and for the like your general purpose programming, GC is the one of the good thing, but it introduces some performance issue as well. So there are advantages and disadvantages as well. So Spark does not use garbage collection. They use their own way to garbage collection the objects which we are creating, which is created during the processing, correct? So there one of the example where they have made it optimal. Spark has its own mechanism to generate the bytecode. If you write code in Java, so there is a Java compiler which create the bytecode, correct? And that bytecode would be executed. But here again they are not using the Java compiler here. You see, they just generate the bytecode and use the Java runtime environment only to run your generated bytecode, correct? So let me give you a little bit on, we are talking about this. Then actually Java, in Java what you do, this is your Java program, correct, written in the file. You compile it, So this is dot java file, correct, and then dot class file would be generated. So this is your byte code, this is your byte code, and this byte code would be run on the JRE, Java Runtime Environment, correct. So what Spark says, whatever compiler you are using, I'll not use it. It is very slow for us. So whatever our Scala code, they have Scala code actually, or you can have Python code. Okay, whatever code you are writing, okay, PySpark code, it would directly generate the byte code their own. Spark would generate the bytecode their own, and that would be still using the JRE to run your code. Whether you use Python, R language, Scala, whatever you use it, they run it. So they won't use the compiler provided by the Java. Okay, they have their own compiler and run it on the JVM. So Spark has its own mechanism to generate the bytecode. All above are the sum of the reasons, okay, to make Spark 100 times faster than MapReduce, correct? Specifically in case of iterative algorithm. So iterative algorithm means if you want to run some same on the same data multiple ways your algorithm, correct. So this is, you want to 10 terabytes of data, you want to sort it, correct. So you have to keep running again and again many steps, correct. So that is become iterative. So you can say like, this is, I am running, so why not keep the data in memory until my processing is finished? Hence keep this data in RAM until all iteration is finished. Generate final result after many iteration. Make it 100 times faster. Sorting of 100 terabytes of data is an example of iterative algorithm, correct. If you know machine learning and data science, then you know what is I mean iterative algorithm. You are processing same data use like again and again with the various tweaking the steps, correct. So tweaking the sample size, tweaking the algorithm parameters, etc., and running it, correct, again and again. So you don't save data on the disk, you will keep this data in memory until you finish it. So we can say that if your application has only one iteration, then performance of Spark equal to MapReduce? Still no, because Spark has done lot many other things like Project Tungsten. They used modern caching L1, L2 and L3, which MapReduce is not using. So even if your algorithm is not iterative, you won't say like your Spark is performance is equal to MapReduce. So in all the cases, Spark would be faster than MapReduce. Okay. So programming languages in Spark. Spark provides 4 programming language support for the Scala, Java, Python and R. So most of the in data scientist world and analytics world, people already know the Python, and people who are working with the Java and OOPS are well aware about the Java, as well as easy to learn Scala for them, correct. So and R is a very similar kind of language as Python. Okay, so you can say Spark supports all 4 programming language, and there is no performance impact. Previously, if you would be using native RDD API, so there was a performance issue. If you use Scala, then it would be fast. If you use Python, then it would be slow. But after introduction of this dataset, data frame, new API, catalyst optimizer and everything, there is no difference in the performance either you use Scala, Java, Python or etc. So it doesn't matter, correct. So Spark convert code in the same structure underline whatever language you use it. So if you know this is your basic structure of the Spark, where the underlying structure is still your Spark core uses RDD, direct acyclic graph. I will in detail will cover this RDD as well. Okay, and this is above this data frame API, and above this you can use Spark SQL engine, you can use structure streaming, you can use machine learning library, you can use RFrame. Use any programming language. Your data source can be Hadoop, HDFS, Cassandra, HBase, PostgreSQL, S3 bucket, MongoDB, from wherever its data can come in, correct. So every whatever language you write your code, this part would convert your code into the same structure and that would be executed by the directory. So whatever code you write it, finally that code would be converted into the Scala, and from Scala it would be generating the bytecode, and that bytecode would be executed on the JRE, Java Runtime Environment, correct? So keep in mind, so like whether you write code in R, Python, Scala, Java, underlying execution engine final is a JRE, Java Runtime Environment, which before that convert your code into the RDD, and that RDD would be executed like RDD API would be used underline to, but you should avoid using RDD API directly and let Spark use them internally. Okay, you should use data frame and dataset API. Dataset API is not required in Python, okay, because of their dynamic programming language. I'll talk about this a little more on later. Okay, so this is about Spark framework, correct? Okay, so now in the Spark framework you can do interactive query, which is generally data scientists do ad hoc queries on the data. They do the queries and see the result kind of thing, correct? Even business analytics also work with the this interactive query. ETL jobs, generally data engineering jobs, okay, so bringing the data to the system, cleaning the data, storing the data for the, so business analytics team and can use it. Structured streaming, if you want to process the real-time data, then business analytics engineer, data engineers, and even data scientists all are using the structured streaming data. I just mentioned like who can use it, but any part can use by anybody, okay, but generally data engineers are focused on the ETL side, okay, and business analytics and data scientists are focused on the like querying the data, finding the insights of the data, insights from the data, etc. So in Spark 2.x you don't have to learn separate API for each framework, so that I told you here, correct? Spark SQL is there, structured streaming is there, machine learning is there, graph frame. So previously what happening when you were using RDD API, you have to learn different API for each framework, but as the invent of the data set and data frame, you don't have to learn separate API for each one, okay? So that is the way the big difference. Okay, so now let's talk about the RDD. RDD is a resilient distributed data set. Is it a data set? Okay, suppose you have a file, okay, let's say you have a file, correct? This big file, if I divide into 3 parts, so this is your one RDD, correct? It would become like this is entire file represent as RDD, and that would be partition, okay? So you can say P1 partition, P2 partition, P3 partition, and this P1 partition can be stored on this, and P2 partition on this computer, correct? P2 partition over here, P1 partition over here, P3 partition here. So this is your some part of your file is stored on this. This is in RAM, okay, in cache. Spark load it, partition it, and cached it across the node into the RAM, correct? So this data is in memory. So this is entire file is represented by the single RDD, but their partitions are some part is stored on this node, some part is stored on this node, some part is on this node, correct? So resilient means recreated in case of machine down. Suppose this machine is crashed, okay, so whatever data is stored in the RAM on this machine would be lost, correct? So and you have only 2 machines in your cluster. So what Spark will do, okay, they will immediately know like P1 partition has been lost, so they would create the P1 partition on one of the remaining node in the cluster to process this data, okay? So that is the that is where it is known as a resilient, correct? Even if you have done some calculation, correct, okay, that is here as an example. Suppose this is your data set, correct? This is RDD. You have done some calculation, 1, 2 and 3 steps you already. Now even you, this is final result is again RDD, correct? This machine crash after doing 3 calculation. Whatever calculation you have done is lost, correct? So Spark knows how to do this calculation again. This is using direct acyclic graph. So they remember like whatever calculation you have done, it knows how to do it. Don't worry how it is handled kind of thing. This is if you want to write your own Spark framework or you want to contribute to a Spark framework, then you need to understand in depth or like how this internally handled. But if you want to use this framework, then no worry, but just need to know this concept. Okay, so this calculation, how it is being done, and in case if it is lost, then Spark can recreate this RDD, even recalculate. So Spark internally redo all the steps on another machine, correct, because that machine which was holding is crashed. It cannot do over here, correct. So it has to do remaining two machine if you have 3 node cluster. So the same thing, correct. So and distributed, resilient distributed data set, correct. So as I mentioned, this is distributed because same RDD is distributed on 3 machines, correct. So that is the reason it is distributed. Similar example I have given here, 1000 lines in your file we divide in 4 partition, P1, P2, P3 and P4. This is your data set. So 250 lines on each machines would be partition. So there are 4 partitions. Data is distributed on 4 machines called 4 partitions. Hence you can work parallelly on each node on different partitions, correct. RDDs are immutable. Once they are created, you cannot modify it. Okay, so suppose here this is our previous example. This is your data. You create RDD1. Do some calculation. So let's say do the transformation. What is transformation actions? I will learn as we move ahead. Okay, but assume it you are creating new RDD from existing RDD by applying some logic. RDD2. So why we are creating new RDD? Because we cannot modify this RDD1. We can read the data from RDD1 and generate a new RDD out of this. Similarly, read the DD2 and do the calculation on this and generate the new RDD. So same RDD can never be modified. So in Java world, if you know, same objects you are keep modifying, correct. But in Spark world, you are not modifying the same RDD. You would be generating new RDD. This is immutable. They don't want to change the existing RDD content because there is some reason, correct, to do all this thing. Spark framework internally implemented this way. Okay, and then finally when action applies, then final result would be generated. Okay, so I'll talk about transformation and actions little later. Okay, so in upcoming session. So RDD can be cached to the memory, correct. So you would be caching it. RDD can be serialized and stored to the disk as well if you are not having enough memory. If you have only 10 node cluster, 10 terabytes of data, and your each node can capable of 256 GB RAM, correct. So it cannot hold entire 10 terabytes of data in memory. So some data has to be on the disk, correct. So it is mixed mode also can be used. So transformation, let me give you an example of transformation once. This is RDD which is holding a one line hadoopexam.com www.hadoop. What I want to transform it, do convert this all the characters in this string into uppercase, correct. So that is one kind of transformation. So this is the code you would be writing in this Spark Scala if you are using it, and so very same way we would be doing in Python, just you would be using lambda keyword over there, correct. So map line for each element in the line convert into the uppercase. Okay, so line dot uppercase, correct. So this would be converting into this. So this is transformation. So this is what I meant to say here in previous, like this won't modify this RDD, it would create a new RDD. So there are in memory, if you see, this RDD is also available and this RDD is also available to you. So both the RDD. So for any other purpose, if you want to use this RDD, again you can use it. Okay, so that is what the transformation, transforming one RDD into the another RDD, correct, by applying some logic. Okay, so that is what the transformation. So we'll go in depth, we'll do hands-on sessions for all this transformation and actions as we move ahead. So this is all about this. And Hadoop framework provides MapReduce, cluster manager, scalable, add node anytime, optimized storage, various file formats, arrow, packet, sequence, ORC kind of thing, simple MapReduce API, fault tolerant, Hive engine, Uzi workflow, lot of things Hadoop provides. That's the reason Hadoop is being used in the industry. It is not going to go anyway, correct. Spark is just a computation engine. Hadoop is a cluster manager, storage engine, MapReduce API, fault tolerant, create as big cluster as you want it. You can run the workflows over there. Lot many things you can do on the Hadoop framework. So don't compare Spark and Hadoop together. Both would be require different expertise to work upon. So Spark is more of a computation engine. So that's all about this training session. Thanks for watching, and I hope you like this session. If you're watching on YouTube, don't forget to subscribe it, and don't forget to visit hadoopexam.com. We are keep adding new sessions on, and so that would be helpful for you. So thanks for watching. Now I'm stopping.